Okay, let's start today's class. Today we will continue to talk about periodic signals. Yeah, we talk about like a little bit CT periodic signals, and today we will like focus on CT periodic signals and DT periodic signals. And let's check today's goals. Yeah, this is today's goals. Firstly, we will review even odd decomposition and continuously periodic signals. And then we will like try to introduce DT, complex exponential and the sinusoidal signals. Yeah. Okay. Before we the first thing, let's review even and and odd signals. And what is even signals? What is odd signals? Yeah. Recall it.
It's just the same about the x-axis.
Axis.
And odd.
You mean the y? Yeah.
Yes, y.
Oh, yeah.
Then odd is the area about the origin.
Yeah, just like symmetric, like respect to the original point. Yeah, and if we like use a mathematic form to represent it, it's just like this. Yeah, xt equal x negative. You can see. For example, here is t, here is negative t. You can see the value will be same. That makes sense to you? Yeah. So this is even like for the odd, you can see the t and the negative t, the value should be like opposite. One is negative, the other is positive. Yeah, you can see that makes sense to you? Yeah, this is just as a mathematic form to represent even signals and odd signals. And then this is for the continuous signal, and this is for the discrete type signals. And any questions for the odd even signals? Okay. And then we know like any signals can be breaking into a sum of an even signal and an odd signals. Yeah. You can see we talk about why any signals can be breaking into a sum of an even signal and an odd signal. We talk about it. Like any signals can be breaking into a sum of an even signal and an odd signal. How? Like why? Yeah, since this is the even part for a signal, right? This is the odd part for a signal. Yeah, if you check the homework I give you, and you will like some homeworks let you to find the even part for one signal and the odd part for one signal. You should use those equations, right? And if you like plus those two together, you will find it is exactly the original one. Yeah, that's the reason why any signals can be broken into. You can see here the signals. I didn't tell you which signals here it is, am I right? Yeah, it is any signals. Yeah, the any signals you can find the even part using this equation and the odd part into this using this equation. And if you add those two parts, and you will find it is exactly the original one. Yeah, that's the reason why any signals can be broken into a sum of even signals and odd signals. And you can see here why the even signals is it's just like you it's just like this, because for the even part of the xt and the x negative t should equal with each other, am I right? And if you half, and it's just the xt for the like even part. That makes sense to you? And for the odd part, it's a similar thing. Xt equal negative x negative t. Yeah, so it's just like the, if you half it, and it's just like the original, like the even part xt. Yeah, that makes sense to you? Any questions so far? Okay, this is just like the continuous, the discrete time signal. It's a similar thing. Just replace t with n. That makes sense to you? Yeah, let me ask you a question. I asked you before. What is n here? What is t here? Huh? Time. Yeah, t here is time, continuous time, am I right? Here, what is a here? Yeah, it is number, yeah. It is still time, but the time is just like the number time. Like for example, the continuous time is just like from 0, 0.1, 0.2, blah, 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 1. Also, you can like for the continuous time, you should get this value, am I right? But for the like discrete time, it's just 0, 1, 2, 3, 4. It's just like this. It's still time, but it's just like the now all the time. Just the like integer time like that. That makes sense to you? Any questions so far? Okay, yeah, this is an even out signal representation. For now, maybe you don't know why we learn this, but those things, those like including like signal transformations like shift, scaling, inversal, and also the even out signal representation, we will like use it later. Yeah, when we deal with the complicated signals. Yeah. Okay. Then we talk about the CT periodic signals. CT signals. What is CT signals? Easy, am I right? Continuous time signals. CT periodic signal, which means these signals are periodic. Am I right? Okay. Usually we use this like define the signal is CT periodic. This is the signal. And if it is periodic, which means T plus this is the period. I plus the period to the T, and it's the same thing. That makes sense to you? Okay. And let me ask you the other question. Like where is here? Like what you can think about what you can think for this one? If I didn't if I equal, what you can think about this one based on what we have already learned? Huh? We have already learned something like yeah, it is shift. Shift, what does that mean? If like a left shift, like a right shift, it's just move along the T axis, am I right? And if you equal, let this equal, which means the original one for this is the original signal. And plus T, which means you just like move it to the left T, am I right? For example, this is T. You move it and you found after you move T and you find it's the same signal. That's a periodic signal because you move period and then you find it's the same. That makes sense to you? Yeah, it's just like the theory behind that. Okay, let's continue. And this is just one periodic signal, and it is continuous time periodic signals. And how to find a unique period? The unique period we also call it a fundamental period, T0 or T0, which we just define it like the smallest positive value of T for which the above equation holds. Yeah, and then let me ask you the other question. What for the CT periodic signals, what is the important thing for us? It's just like find the fundamental period. Am I right? If we found the fundamental like period, which means we can find the rule. Am I right? For these signals. Okay, we will talk about how to find the fundamental period later. And then for in last class, we talk about the periodic CT complex exponentials. And do you know why? Do you know why we talk? Why we like just like point point the exponentials, complex exponential signals out? Why not other signals? We talk about this in last class actually. Why not other class for other like signals? For example, you know like the line signal, a line, or maybe unit step signal, or maybe impulse signal. Why we talk about the exponential complex exponential signal? Why? Because here, we know for the complex exponential signals, what equation we can use? Euler equation. Yeah, we can use Euler equation. We can transfer it to the sinusoidal signals. I'm right. And I give you a very important statement in last class. Do you remember that? Actually, any periodic signals can be represented as a sum of sinusoidal signals. Do you remember that? Like any periodic signals can be like a generated from a group of sinusoidal signals. Yeah, do you remember this one? Actually, I also talk about this in microelectronics. Yeah, that's the reason why we talk here. We talk about like complex exponentials because the fundamental thing for the complex exponentials is just sinusoidal signals. And then the sinusoidal signals can represent every periodic signals in the real world. Yeah, so that's the reason why we point this out. And also, we know this is like a complex exponentials. Usually we just define these signals like this. Yeah, this is just a definition. And then we know it is periodic because you can transfer it to the sinusoidal signals. And if it is a periodic signals, we know that periodic signals have this property. Am I right? So which means it must have a period. This one. Yeah. From this equation to this equation, I think you are familiar with this, am I right? This is exponential equation, fundamental. Yeah, and then if it is a periodic signal, which means this one should equal the original one, am I right? That makes sense to you? Yeah, and then which means this part should be equal 1. The second part should be equal 1. That makes sense to you? Yeah, and then this one should equal 1. And then we just know, because if you want this one equal 1, and which means this part should be equal to 2 pi k. This is like a math we review in last class. Yeah, and then which means t should equal omega 0 divided 2 pi k. Am I right? And here, actually, we want to find the fundamental period, which is t0. The smallest positive value of t, like 1k equal 1. That makes sense to you because t should equal 2 pi k divided omega 0. And if k is an integer number, a positive integer number here, you can see here, k belongs to z. What's z? Z is like a positive integer number. Yeah, so which means the smallest k should be 1. Am I right? So which means the smallest periodic should be should equal 2 pi divided omega 0. That makes sense to you? Okay, and then we define this one omega 0. We define it as a fundamental frequency. You heard of frequency before, am I right? We usually use F to represent a frequency, am I right? Yeah, you know that, am I right? So frequency, what's the relationship between frequency and the period? You know? Frequency and the t. Do you know what's the relationship between frequency and the period? Actually, this one is. Huh? Equal what? Yeah, equal 1 over t. Yeah, this is yeah, am I right? It's like yeah, this is just like a very fundamental thing. And but here, this is a fundamental frequency. This one actually, if you observe, you can see this seems a little different with this one. Am I right? We talked about it before. Yeah, we will talk about what's the difference? And you can see here. Let's talk about the other signals, the sinusoidal signals. Yeah, the sinusoidal signals, like I said, it is obvious, very important. So here, and it is a real signal closely related to the periodic complex potential is a sinusoidal. We define the sinusoidal signals like this. Yeah. Do you have any question about this definition? Why we don't use the sin? Why we use cosine here? Huh?
It's the frequency.
Frequency?
Or use cosine, it's not 100%.
Okay. I think you can solve now. Actually, the sin and the cosine, the basic thing is the same thing. Am I right? The cosine can be transferred to the sin can be transferred to the cosine. Only the like a pi/2 difference. Do you remember that? Yeah, so it's the same thing. You can use sin here, but here we use cosine here. Yeah. Actually it's the same thing. And here, did you notice here? This omega now, actually it is we call it angular frequency. Here, this frequency, we call it normal frequency. It's just like the frequency we usually talk about, like the 1 second, for one second, how many cycles, all right? Yeah, T is just a period, and like 1 cycle is just a column. And this, we call it an angular frequency. And let's talk about, yeah. Actually, we have this equation, the angular equation equal to pi or multiple T, which means the angular frequency and the normal frequency has some relationship. Yeah, has this relationship. You can transfer like a angular frequency to the normal frequency, also normal frequency to the angular frequency. Yeah, and then this one, if you use the normal frequency, you can write this equation here. Any question? Okay, and then yeah, this is just like the frequency we usually talk about. The fundamental period for the sinusoidal signal, we usually use this equation to represent 2 pi over omega 0. Actually, it's you can see it is the same with exponential, like complex exponential signals. It's the same thing. That makes sense to you? Yeah, because like I said, the basic, the fundamental, the complex exponential is just the sinusoidal signals. Yeah. Okay. Any questions so far? Okay, let's continue. Yeah, this equal 1 over f0. This is just the normal frequency. Yeah. Okay, let's try to. Okay, let me ask you again these questions. If we talk about the periodic CT signals, what's the most important thing for us? Usually, what things we want to find? The period, am I right? Yeah. If we know the period, we know the rules for these signals. So let's talk about how can we find the period. Okay, let's try to like through some examples to find the period. Let's determine the fundamental period of the signals, these signals. Okay, and let's talk about this one. Here, these signals is like it's generated from like 2 different sinusoidal signals. Am I right? Okay, how can we find this signals periodic, fundamental period, fundamental period? Actually, we can find the separate ones and then try to find the, yeah. Let's talk about the first one. Yeah, what's the first one's like a period? Here we know if you observe this one, and we know the omega 0 is none. Am I right? Yeah, this because there are 2, so here is omega 1, and here will be omega 2, and omega 1 equal none. Am I right? So what's the period? we can use the equation here. 2 pi over omega 1, am I right? So which means which will be 2 pi over 9, am I right? So the period should be this one. And for this one, what is omega? This one? 6, yeah. And what is the period? 2 pi over 6. So, and it is pi over 3, am I right? Yeah, this is the same thing. And so, like for now, we have this signals period, and we have this signals period. And how can we find the like a whole period? Then we need to find the least common multiple of T1 and T2. And it is just the LCM T1, T2. Have you ever heard this before? Yeah, because you can see you have this period and you have this period. You should find the least common multiple. I'm right to meet. This period should is the period for this one, also is the period for this one. That makes sense to you? Any questions so far? Okay, let's talk about how to find the LCM T1, T2. Okay, we know if we want to find the fundamental period, and the fundamental period should equal T1, T1, also equal T2, T2. That makes sense to you? Yeah, we should find the least common multiple of T1, T2. We should find here, the most important thing is we need to find T1 and T2. That makes sense to you? And from this equation, we know T1 equal T2, T2. T1 equal T2, T2. And then we know T1, T2, am I right? So T1, T2, T1 over T2 equals T2 over T1. We have this equation, right? We know this one and this one and this one. So we can get this equation, this value, right? So let's do that. Yeah. And for this equation, we have this one, and then it will equal this one, right? So for now, you need to find the P1, P2. And how can you find it? The fraction must be simplified so that the numerator and the denominator are co-prime. That makes sense to you? Yeah, because here we get 9 over 6. Is it the simplest value? Like the numerator and the denominator are co-prime.
That would be 3x.
Yeah, because you can see it can be divided 3 both. Am I right? Yeah, so if you find the T1, T2, you need to pay attention. If you use the T2, T1, and here this value should make the numerator and the denominator are co-prime. Yeah, just remember that. So which means this equation should equal this should get this one. You cannot stop here. Just remember that you cannot stop here. You need to stop here. Am I right? So then we can for the T1, T2. What's the T1, T2? Then we can easily to find the K1, K2, am I right? The K1, K2 should be the smallest value, like meet this equation, am I right? That makes sense to you? Yeah. So the K1 should equal 3 and K2 should equal 2. That makes sense to you? So what's the period? What's the like a common period? The smallest common period should be equal K1, T1 or K2, T2. I'm right. Here it should equal what? What is T1? This one, I'm right. What is K1? 3, I'm right. So what is the period? 2 pi over 3. Am I right? Yeah. And if you put a K2 multiple this one, it's same thing, 2 pi over 3. So the T should the t is equal 2 pi over 3. Yeah, that makes sense to you? Okay, yeah, this is this example. And this example like teach us how can we find the common fundamental period for like a combination signal. Okay, let's talk about this one. How about this one? How about this one? Do you remember? Yeah, did you notice here there is a power here? Am I right? So you need firstly you need to try to remove this power. How? Do you remember?
Sure.
Actually, there is an equation. I don't know if you remember that. This one. Yeah, this equation. I think this is a fundamental sinusoidal equation. Have you ever seen this before?
I've seen it over the name.
Oh, you don't know the name, but you.
Yeah, I've seen that.
Okay, yeah. Yeah, this is just like yeah, I also don't know the English name, yeah. But you just remember that if you see the like power sin for cosine for sin, and you can use this equation. And after you use this equation, you can get this one. It doesn't make sense to you? You just like put 2 into this part, and then it will 4t minus 2 pi over 3. That makes sense to you? Yeah, any questions so far? Any question? No? Okay, let's observe this one. So what is omega? What is omega? Yeah. Sorry, omega is 4, am I right? So what is t? 2 pi over omega, am I right? So what is 2 pi over 4? It will pi over 2. That makes sense to you? Okay, that's great. Any questions so far? Okay, let's talk about the other one. How about this one? Let's talk about this one. And what is omega 1? This is, for example, this part is, let's talk about the first part. What is omega 1? 3 over 5, am I right? Yeah, so what is t? T1? 2 pi over omega 1, am I right? Yeah, so then we can get this one. That makes sense to you? So what is omega 2? Yeah, 9 over 3, but 9 over 4. Yeah, so what is t? T2? 2 pi over omega 2, am I right? So we can get this one. Yeah, does it make sense to you? Yeah, so what is like the fundamental period for this this signal xt? We just talk about that. Using which equation? Like for now we want to find the t0, all right? So t0 equal what? Oh, what's the next step? We need to find what? Yeah, k1, k2, am I right? Yeah, so we need to find k1 multiple t1 equal k2 multiple k2, am I right? K2 multiple t2, am I right? Does that make sense to you? Any question? Okay, and then we know t1, t2, am I right? So k1 over k2, yeah, we just like repeat the same process. Like k1 over k2 equal t2 over t1. We know t2 here. We know t1 there, and then we just put t2 t1 in this equation. This one, am I right? And then try to simplify that. It will equal this one. Am I right? That makes sense to you? And then equal this one. It will. And finally, it will equal this one. So is it the simple, the simplest one? Is this the simplest one? Yeah, it is. So what is K1? What is K2? Yeah, that's right. K1 is 4 and K2 is 15. Yeah, that makes sense to you? So what is the T now? T0? Just put it back. Yeah, 4 like a K1 multiple T1, am I right? T1 is equal to this one. So multiple 4, am I right? So it will be 40 pi over 3, am I right? That makes sense to you. Or you can put 15 into this equation, like 15 multiple like 8 pi over 9. It's a same value. Yeah, that makes sense to you. Yeah, this is like this example. Any questions so far? Yeah, like just remember if for this kind of signals, you just use these steps to find your fundamental period. Okay, let's see the other example. How about this one? There is not only like there are not only 2 atoms, there are 3 atoms. What should you do?
Just add another T.
Yeah, then you will think there will be K1, K2, K3, am I right? Yeah, that's a method, but I will teach you the other method. You can see usually if you just use three things, like also T3, am I right? And then you need to use T3, and you need to guarantee K1 divided K2 equal K2 divided K1, and T1 over K3 equal to T3 over T1, and then like these two, like T2 over T3 equal T3 over T2. You need to guarantee those 3 equations, am I right? So like when you try to resolve those 3, maybe it will like make you mess up. Yeah, make you confused. Actually, usually, if there are more than 2 periodic functions, yeah, there are 3. Group them in pairwise to find the fundamental frequency for the whole signal, which means, firstly, you just find those 2. Am I right? Actually, you can see this is just this one. Am I right? You have already found it. So you just find these 2, and then you find this one. Yeah, this one is just like we have already found it, this one. Am I right? So you find these 2 is this one, you find this one and this one, and this become 2 different atoms. Am I right? So you use the same process to find the T0, T0. That makes sense to you? Yeah, this process will make the question simple for you. Does it make sense to you? Yeah, and then how can we find the final fundamental period? It seems, yeah, like find the K1, K2 for this T1, T2, am I right? Yeah, the same thing. Am I right? Yeah, so let's try to find it together. Here. Yeah, for now we know like we need to find T1 divided T2, so T2 equal T2 over T1. That T2 is pi over 2, am I right? And divide like that one is 40 pi over 3, so it will equal like 3. So it will 3 pi. It will equal 3 over 80. Am I right?
没那么好。
Huh? That makes sense to you? Yeah. That makes sense to you? Yeah, because you can see here, pi divide, which means it will multiple. Yeah, pi will be removed, and this is 3 over 80. Am I right? Yeah.
Well, it's the 45.
Yeah.
It said 3 over 45.
Yeah, because we should calculate T2 over T1. Am I right? T2 equals 2 over pi. Am I right? And then we need to divide 40 pi over 3. But then I don't know if you learned this before. If you over this one, which means you multiple flip. So you multiple 3 over 40 pi. Does it make sense to you? Yeah, so it will equal 3/80. Yeah, because I don't know how can you calculate this equation. Usually I calculate like this, but it's the same. If you use your way to calculate, but it will have the same like result. Yeah, it will be over. And then what is Q1? Yeah, you can see this is this the simple is one. Simple is it. I think is that right? So which means P1 equal what? 3 and P2 equal what? 18, all right? So then we can find the T0 equal T1, and K1 is 3, and T1 80, 40 pi over 3, am I right? So it will be 40 pi, am I right? That makes sense to you. So which means T now should be 40 pi. Fundamental period should be 40 pi. That makes sense to you? Yeah. Okay, any question so far? Yeah, it's the same process, same steps. Any question? Okay, yeah, let's continue. Let's talk about this one. How about this one? What is the omega 1? What is omega 1 for this signal? Yeah, 3. So the T1 should equal 2 pi over 3, am I right? What is omega 2? Yeah, it is pi. So the T2 should be equal to, am I right? Okay, let's try to use this equation, like find K1, K2, am I right? And K1 over K2 equal T2 over T1. And then we put T1, T2, T1 in this equation, and then we get this one, am I right? Okay, let's talk about what is K1, what is K2. Yeah, actually this one is a tricky one. Yeah, because we talk about the K1, K2 should be integer positive value, am I right? Number. But here there is a pi, am I right? So which means K2 will never be an integer positive number, am I right? So for this situation, this one, no, this one is no answer. The truth is, this signal is a non-periodic, it's a non-periodic signal. That makes sense to you? Yeah, because you cannot find a fundamental period for this signal. Am I right? Yeah, does this make sense to you? Okay. Any questions so far? So, like when you find some periodic for some signals, you need to pay attention. Like some signals are not periodic. Yeah. Okay. Let me ask you the other question, the other tricky question. Is this signal, like, is this cosine 3t plus 1, is this a periodic signal? Is this one? Is this a periodic signal? Yeah. And is this a periodic signal? Sin pi t minus 1. Actually, this one it is. Yeah, but some you need to remember, like some periodics combine them together, it now like have to be a periodic signal. Yeah, you need to pay attention to that. Okay, let's talk about this is CT periodic. Let's talk about the DT periodic signals. Yeah, the DT periodic signal actually is similar with CT, and the difference is just like my period is not T, it's just N. This N, what is this N? This N is just a term, am I right? But this term should be integer term, integer like a number thing. Yeah. Okay. The similar, yeah, for example, this one is like a signal. And how to find the unique period, capital N? Yeah, this is you can see here. Do you notice like from here to here, it's a signal. From here, it will repeat. From here, it will repeat, am I right? Which means the period should be 1, 2, 3, 3, am I right? Yeah, so, but how can we find this one is quite simple for us. But for some complex signals, what should we, how can we find the like unique period? Yeah, first let's try to like define what is unique period n. Usually, like the CT, the smallest positive value of capital N, like of which the above equation holds, is called the fundamental period N naught and or N0, and the fundamental frequency, like you can define 2 pi over N naught N0. Yeah, this is like the we need to find the smallest positive value. Yeah, it's just similar with CT's signals. That makes sense to you? Yeah, so which means we should find the smallest positive value of n. Okay, let's try to talk about how can we find it. Before we talk about how can we find it, let's talk about two special signals. One is DT complex exponentials. Actually, it's a similar thing. Yeah, a group of important DT complex exponential signals we can define like this. Yeah, it's similar with the CT. Yeah, just like you can see, notice the difference is here. There is a N and a C, which means it will have a magnitude. Yeah, that makes sense to you? Yeah, so yeah, just don't confuse this one with this one, because yeah, you can see this one is continuously. Here is a T, but here is N. So when you like try to deal with some signals, you need to pay attention to. Okay, and then DT sinusoidal signals and complex exponential signals. Yeah, we can define the, this is just the DT complex exponential signals. This is the DT sinusoidal signals. We define it like this. And the difference between this and the continuous CT sinusoidal signal is just here is N. Did you notice that? Yeah, and then, yeah, don't confuse with the CT continuous signals. And the Euler equation links two signals, links this one and this one. Not be confused to this one, those two, using this equation. And this equation. Yeah, it's just similar with CT. Yeah, and you can see this is just a Euler equations. And if you use Euler equations, you can easily to like find this part will equal this part, and this part will equal this one part. But just pay attention. Here is n. All are n, not t. Yeah, it's just for the dt signals. Yeah, any questions so far? Okay, and then let's try to, yeah, because you can see, actually for the DT complex exponentials, it's also, we know it is periodic, yeah. And then, which means those two will be equal, am I right? Yeah, and then it's the same thing, and which means this part should be equal 1, am I right? And we know like this one equal 1. So which means, what does this mean? This means this one should equal 2 pi k. Am I right? That makes sense to you? And then n should equal this one. That makes sense to you? So what is k here? K is any like an integer positive number. Am I right? What is n here? It's a positive like integer number. Am I right? So if we want k is a positive like an integer number, and n is a positive integer number, what is omega 0 here? Like is there some condition for omega 0, omega naught or omega 0? Is there a condition?
Also has to be, or does it have to have pi in?
Yeah, you got that. You can see here is a pi. If we want this one is a positive like integer number, if we want this with positive integer number, which means we need to remove this pi, am I right? So which means this one should include pi to remove that pi. So for this situation, yeah, what is the requirement for the signal to be periodic? If this one is periodic, the omega naught is a rational number times pi. That makes sense to you? It will be like pi or some half pi and like 3 over 4 pi, yeah, anything, but it should be a rational number times pi. That makes sense to you? Yeah, otherwise you cannot find like a proper n, capital N. Does it make sense to you? Okay, let's continue. Let's try to find this one. And for the first one, what is omega? What is omega 1? Yeah, you can see here. Yeah, omega 1, omega 1 should equal what? Yeah, just 1. So what is n? N equal to pi k over omega 1 is equal to pi k, am I right? So what is n1? We should find the smallest. So smallest, yeah, yeah. Oh, sorry. Yeah. It should be equal to pi k, am I right? Yeah, you can see no matter k equal what, the n1 is just like n1 should not be a positive integer number, am I right? So which means it is not paired, am I right? That's because the omega 1 equal 1, like the omega naught. Here we talk about it is a rational number times pi, am I right? But here it is a 1. So that makes sense to you? Yeah. Okay, let's talk about the second one. What is omega? This omega? It is 3 pi over 7. Am I right? So what is n2? It is 2 pi k omega. It should be 40 k over 3. So what is smallest n2? What is k? Make the smallest n2 is a positive integer number like that. It should be k should be 3, am I right? And the n should be 40. Does that make sense to you? Yeah, otherwise it will be bigger than 40 like that. Does that make sense to you? Yeah, any questions so far? Any question?
So basically get for A over the negative 1.
You mean what? So you just use this equation, and then you get this one, am I right? Try to find the smallest positive like integer number for n2, and you just you mean just try different value, am I right? Like that? Yeah. You just, but sometimes it will be not like difficult. Yeah. That makes sense to you? Yeah. Any questions so far? Okay. And let's try to find the other. Talk about the other example. Yeah, for this one, what is omega 1? Yeah, and what is n1? 2 pi k over omega 1, right? So it will be 3 k. So for the smallest n1 should be what? 3, am I right? And for the omega 2, what is omega 2? 3 pi over 4, am I right? Yeah, so what is n2? Yeah, like this, am I right? Yeah, so it is 8k over. So what is n2? Like find the suitable key to make the key n2 is the smallest positive number. Yeah, it will be 8. So what is the fundamental pair for the whole signal? Yeah, for now you need to find the least common multiple. What is the least common multiple? I think this one is easier for you. 3, 8, you find the least common multiple. It should be like 24, am I right? Yeah, so this is just like how to find the fundamental pair for CT signals and DT signals. Yeah, and we usually just talk about the sinusoidal signals or exponential signals because the any periodic signals can be like transferred to like a sinusoidal combination. Yeah, that makes sense to you? Any questions so far? Okay, this is today's class, and we will have the new homework. I will put it on Blackboard and also give you some solutions. And what do you need is just find out how can you get these solutions. Yeah, any questions? Okay, that's great. Okay, and take care. And okay, when you drive home, just be careful. Yeah, and watch out. Yeah. Huh?
So that's the midterm, not the, yeah, right?
The midterm is just the first exam. Yeah, but this one, oh, yeah, this one I think is the wrong thing.
Okay,
Yeah. Sorry. I think this data. No. Yeah, no. This data is not right. Yeah, I will like fix it. Okay. Yeah, any question, just let me know.
Thank you.